Dear student, thank you for watching the communication playlist session. So let's continue our previous session. So next example of the PCM is that consider a PCM system with an accuracy of about plus minus 0.1%. So usually we write it delta by 2 and the answer is usually in percentage. So the analog signal has a maximum frequency of 100 hertz and amplitude of minus 5 volt to plus 5 volt. So this is X min and that is X max. So X the levels the range is given, the accuracy is also given, and then you need to calculate these few questions that determine the maximum required sampling rate f of s. Determine the maximum number of bits required to represent each PCM word, so that is the N. Determine the minimum bit rate required for the PCM signal, that is PB. And fourth, determine the minimum absolute bandwidth required for the transmission of PCM signal, that is B. First one was the sampling rate, so that is straightforward and very easy because the maximum frequency is given 100 hertz. So you need to multiply it by 2, so that is will be the sampling rate, so 200 hertz. The other one was you need to calculate the number of bits n. So for the number of bits you need to see what is the value of l, and we know this signal is non-sinusoidal signal because we are talking about the PCM signal with an accuracy of that one. So it means that the signal is non-sinusoidal signal, like uh, here. So if the signal is non-sinusoidal, in that case the value of L, you can write the formula, that is 2 multiplied by x max divided by delta, and you know delta can be calculated from the accuracy, so which is delta by 2. So the accuracy is 0.1%, so multiplied zero point 0.1 with 100, the answer is 0.001. And we know x max, that is equals to 5 volt. So delta is also given. So x max, so that if you write that 2, if you take that 2 here, so it will be delta by 2, and delta by 2 is your accuracy. So the x max is 5 volts, so 5 volt divided by 0.001, the answer is 5000. If L is 5000, you can use that formula, n is equals to log 2 L. So L is 5000, so if you simplify this you will end up 12.28, and then you are usually approximating its upper value, so that is 13 bits. The third one was bit rate. So we know bit rate is number of bits multiplied by sampling rate. So number of bit we have already calculated 13, and sampling rate is also calculated, that is 200, so it is 26 bit per second. Fourth one is transmission bandwidth, which is we know that is equals to number of bits multiplied by the bandwidth of the message signal. Number of bit is 13, and bandwidth of message signal 100, so that is equals to 1300 hertz. So I know that you understand this example. So let's have another example for better understanding. The signal xt is equals to 2 sine 2000 pi t minus 4 sine 4000 pi t. So this is given. So that need to be quantized using a 12-bit quantizer. So n is also given. What is the RMS quantization error? You need to calculate the quantization error and the quantization SNR. So we know the already the mean variance of the quantization, that is equals to delta square by 12, that we have already derived in our previous sessions. So you can write this in this format as well, like delta you taking square root on both sides, so delta by 12 square root, and the quantization SNR, that is power divided by the signal power divided by noise power. So the first was the RMS quantization error. So delta is equals to sigma is equals to delta by 12. So take this as equation A. So what is delta? So delta is 2 multiplied by x max divided by L, and we know calculate the x max. So from the given signal 2 sine 2000 pi t minus 4 sine 4000 pi t. So we know the x max for sine. Actually, we need to have a different combination of, because we know that sine ranges from -1 to +1. Okay, so using different values of sine, like here we can use maximum value of sine, this is +1 multiplied by 2, minus here we can use the minimum value of sine, that is -1, and then that is we can have 6. So you can use different value, and the maximum max x max will be 6 in that case, because you need to take the x max. So use this in this equation. So x max is 6 multiplied by 2 and then divide by L, and we know L is equals to 2 raised to the power n, and n is given, that is 12 bit. So delta is equals to by 6, that is 12, divided by 2 raised to power 12. So if you simplify using your calculator, the answer is 2.93 into 10 raised to power minus 3, and use this value in equation A. So sigma is equals to 2.93 times minus 3 divided by 12 under roots, and if you simplify this, you will end up with 8.45 into 10 raised to power minus 4. The second question was quantization SNR, which is equals to input power divided by noise power. So for input power, we have usually we can say the formula of the power is the peak value square, amplitude square divided by the 2. And in the given question, so here the amplitude is 2, so 2 square by 2, and then 4 square by 2. So similarly, 2 square by 2 plus 4 square by 2, so which is equals to 4 plus 16 by 2. The answer is 10 watt. So that is signal power. The here noise power that we have calculated here, standard deviation of 8.455 into 10 to the power minus 4. Take the square of that. That is the noise power. So here I forget to write square. You need to write square here, and then if you wanna write in dB, so you can write this value in dB, like 10 divided by 8.457 into 10 to the power minus 4 whole square. So and then you will end up with 71.45 dB. So let's solve another example, last example of this session. So an input signal applied to PCM has a maximum frequency of 4 kilohertz, and the input ranges from minus 4.8 to plus 4.8 volt. The average power of input signal is 30 milliwatt. The target output SNR is 20 dB. Assume uniform quantization and PCM produces binary output. So the range is given, maximum frequency is given, SNR is given. So you need to calculate the number of bits required to represent each sample. You need to calculate n, and then you need to calculate the transmission bandwidth, because the non-sinusoidal signal, because inputs applied to the PCM, so it means that the signal is non-sinusoidal. So for the non-sinusoidal signal, SNR is written in this format that we have tried in our previous session: 3p divided by x max whole square multiplied by 2 raised to power 2n. So we know that SNR is given, that is 20 dB. So and this formula is in linear magnitude. So we have to convert dB into linear value. So if you convert dB into linear value using this formula, like 10 raised to the power, so 20 divided by 10, which is equals to 10 raised to the power 2. So you can use 100. You can use 100 in this equation P. So 3 multiplied by 3, so sorry, 100 is here, 100 is here, 3 multiplied by p is also given. So like the power is 13 to 10 raised to power minus 3. You see 30 milliwatt. So 13 to 10 raised to power minus 3. So x max is also given, that is plus 4.8 volt. X max is also given, 4.8 whole square multiplied by 2 raised to power 2n. So you can take rearrange this value, and then you will end up with this term on left hand side, and then 2 raised to power 2 and on right hand side. You can take log on both side, and then you can solve for the n, which is approximately equal to 8 bit if you use your calculator. The second is the transmission bandwidth, so number of bit multiplied by bandwidth of the signal. So we have already calculated n, that is 8 bit, and the bandwidth of the signal is also given, which is 4 kilohertz. So 8 multiplied by 4, that is 32 kilohertz. So that's all for this session of examples. We have done many examples in our different sessions. So if you want to understand thoroughly, you need to watch all the this session and the previous session as well, so that you can completely understand that how the questions are given and how can you solve for different scenario, for different type of signals, sinusoidal signals and non-sinusoidal signals. So, but still, if you have any question, you are most welcome to ask in the comment box, and we will try our best to answer the question. Thank you for watching the video.